Hey, everybody. So I'm going to briefly talk about the NIM SDKs, specifically looking at our TypeScript SDKs, which means you can access the Mixnet from and in the browser, and then I will demo them for you. All of these are deployed live as well, so I'm actually just going to be going through some stuff that is already deployed live on our documentation, because that's just how easy these things are to do and to show you. So yeah, my role is DevRel/integrations. So I maintain our docs, I write our SDKs, and I work on integrations as well. Just a quick overview of like why would you even build something like a Mixnet? All of the things that we think about when we think about privacy. So like end-to-end encryption doesn't necessarily protect you against the kind of privacy adversaries that we're dealing with today. Regardless of whether the content of something is encrypted, you leak loads of metadata. So information about the connection that you're making, your IP address, the timing it was made, probably what device it was made from. All of this stuff can be used to kind of de-anonymize you. If we're thinking about messaging apps like Signal, if we're thinking about some like cryptocurrencies, so we heard about privacy on Ethereum. If you imagine that that's kind of the application layer, then you might be doing all of this kind of wonderful on-chain privacy stuff, but if you're leaking your IP and where you're making transactions from and at what time, then it feels like you've only got half of a solution. VPNs don't necessarily also help you. Centralized VPNs, you're just trusting them to not sell all of your data. Lots of them do, or they can be leaned on. And even stuff like Tor, then if your adversary can kind of watch all the ins and outs of the entire network, then you're not necessarily as defended as you were in the past. And unfortunately, this kind of adversary is something that, I think when Tor was being designed, that was kind of seen as sci-fi, but now it's unfortunately very real. So what actually is a Mixnet? A Mixnet is an overlay network. We refer to like a noise-generating Mixnet because I think the image is there that you're essentially trying to create, the kind of you're trying to create the kind of, let's say, the computational version of like white noise or static, where it's impossible to pick any identifying individual pattern out of it, right? That's the kind of image to keep in mind. We route traffic in a not dissimilar way to Tor, so everything is kind of multiply encrypted, and it goes through multiple hops, right? This is something that people will be very kind of familiar with. We then add a couple of other features to it to basically prevent against like traffic analysis and timing analysis. So we use something called cover traffic, or basically instead of traffic only leaving your device when you're actually doing something like submitting a transaction, you're kind of constantly sending out traffic that all looks the same and is basically just empty encrypted payloads. And the reason to do this is because, again, if you're only hiding the contents of what you're sending, but you're not hiding when you're sending it, that's a data point that could be used to de-anonymize you, right? So you want to obfuscate that. You also want to obfuscate the kind of the fingerprint of that traffic as well. So, just from doing kind of on-the-wire packet analysis, you can start to build up relatively accurate models of like, is this an HTTP download? Is this an email? This kind of stuff, right? So here's just a quick kind of architectural comparison. Don't have too much time to get into it, but especially look at the kind of the difference between Tor and between us. And now onto the SDKs, the stuff that I'm actually here to talk about. That big QR code is just going to our developers page if you can't be bothered to type it. We have two types of SDKs. We have the Rust native ones, or like Rust native kind of crates and SDKs. So this is for your CLI apps, your desktop apps, or mobile, if you want to cross-compile for it. We also have the TypeScript SDKs, which is basically just TypeScript bindings around a bunch of WAS and blobs that I've made from our Rust code. And this means, which is the stuff that I'm going to be demoing for you, you can basically embed your Mixnet client so you can access the Mixnet from anything that has a web view, so browsers, JavaScript apps, all of this kind of stuff, without leaking all of that kind of important metadata to those things. We have a couple of approaches for like basically abstraction. Some people want very, very high-level abstractions. They want to go, well, I just kind of want like a drop-in replacement for an HTTP request, and it just goes through the Mixnet, and it's private, right? So this is the stuff that I'll kind of be demoing. This is the high-level stuff on the bottom, but we kind of this is stuff that's been built up from, the kind of, say, raw messaging SDKs, which if you looked at our stuff a couple of years ago, those were the only things that you would have seen. So really now we're trying to cater for, basically every level of kind of configurability that developers might want or have. Instead of going into these different kind of diagrams just because, which is kind of different ways that stuff goes through the Mixnet, what I'll do is I'll actually spend some time on the demos, and then if we have time afterwards, then we can do that. So if you actually want to try out any of the demos as I'm going through them, you can just scan that QR code. I have tried them, and they do work on most mobile browsers, apart from Vanadium, if you're a Graphene user, which for some reason it doesn't like the size of the WASM blob that I'm pulling in, but I'll work on that in the future. So what can we see here? What we're actually seeing here is, let's just go through some very simple embedded stuff that we have in this web page, right? So right here, we're actually on our documentation site, and this is a playground. Lots of stuff has playgrounds online where you can quickly try stuff out. So what we're going to do is we're going to do a couple of things, and it might seem a bit weird for a demo to be opening up the network tab of your browser, but bear with me because it basically proves my point. So if you've ever looked at the networking tab of your browser when you're doing stuff, then what we're seeing here is we're basically seeing all of the outgoing network requests that are being made by your browser window when it starts up. All web pages will do this. They'll load something from a CDN, probably. If you're making GET requests, DNS requests, whatever, then they'll also be externally making calls, right? And they'll be accessing stuff like your browser certificate store, which the browser, for very good security reasons in the past, so you don't get man in the middle, doesn't give you access to, right? But that's obviously, from our privacy perspective, a problem. We don't want to be leaking anything ClearNet in terms of, like, I don't know, if we want to do DNS maybe, or if we want to make private HTTPS requests. We don't want to be leaking our IP address. So how do we get around that? What we're doing is we're basically loading we're loading up the TypeScript SDK now, right? So all of these GET requests that are happening here, this is the kind of the bootstrapping of your NIM client. So we've made some requests. All of these have been going to various kind of like NIM endpoints, bootstrapping the topology, getting all of this. We've now connected, right? So we have our tunnel. And these two here, these are basically our WebSockets. Your connection from a client into the Mixnet is a WebSocket at the moment. So all of our other requests now will go through these WebSockets. We won't see any more network requests actually popping up over the course of this demo, and if we do, then I've made a terrible mistake. So what do you want to do first? We can do DNS resolution, maybe. So again, we're not, oh my God, that's a big bug. Sorry. So if we actually switch over to our console, what we can see is we're actually making DNS queries through the tunnel. In this instance, we're hitting something like, we're actually hitting Google there, but we could, instead, what we could also do, which I should have showed you before. Sorry, those warnings are because MetaMask is trying to load itself. All of this stuff is like very, very configurable as well. So you have like different DNS endpoints that you can set. You can force it to only use TLS. You can also disable some of the cover traffic stuff if you want to. That's kind of it's good if you're trying to debug, but maybe don't do it. So let me just reconnect our tunnel. So our tunnel's up, that's nice. And what we can do now is we can, okay, cool, so we've just done private DNS resolution from the browser without leaking to our browser what DNS we're trying to resolve. That's quite nice, right? We can also maybe connect to a WebSocket echo. And let's have the DNS resolution there, it took less than a second. So I think in terms of the, let's say, privacy to latency trade-off, I think that's pretty okay for everyone. Yeah, so now we are connected. We are tunneling through to a WebSocket echo service, right? We've done TCP, we've done TLS. All of these endpoints, all they see is basically the exit gateway that you're attached to. They just see their IP. But otherwise, it's a completely normal, it's a completely normal formed request. And what I mean by that is that in this WebSocket tunnel, right, actually in our WASM blob, what we're doing is we're actually basically creating IP packets. So if we want to look at this, then what we're actually doing is we're actually like, in our client over here, we're actually constructing all of this as like proper IP packets, routing all those IP packets through our tunnel, and kicking them out the other end. So for all of our, for DNS resolution, all of that, it's just the exit gateway that's being dealt with. For stuff like TLS, TLS actually terminates in the client, and the way that you do that is you just bundle all of your certificates, you bundle all your certs at compile time. So basically, all of the certs that are in here, the stuff that otherwise you would have to query your browser for and leak everything to, is the Mozilla CA store that's bundled in at compile time, which for these was like a week ago when I released them. So they're that's simple stuff. But we can also have a look at how you would start to integrate it. So there's two kind of simple demo integrations that I've done. One is ENS resolution and IPFS resolution over the Mixnet. And this code right here, this 20 lines of code, that's all you have to write to do this. So that's just some shim code. Otherwise, you're using Ether.js as per normal, and you're using our mixfetch package. And that's because the browser's fetch API, which is the thing that we're replacing here, right, is kind of patchable. So you can basically tell Ethers, hey, instead of using the browser's fetch API, just use ours. This is the only code that you have to write to then basically access ENS and IPFS through the Mixnet. So if I press this, we already have the tunnel up from the other page, so that's nice. So what we're going to do is we're going to ping and actually try and resolve which contract the stuff that we want to pull down is. In this instance, Vitalik's IPFS website, which is registered on ENS. Okay, so we're doing all this through the Mixnet. We've got the content hash. Right, now we have the CID. Perfect. And so let's fetch it. And actually, if I open up our network panel again, then we can actually, we can see the console. So what we can actually see, if you want to dive into this, like by looking at it yourself, you can actually see that we've done DNS resolution. We've actually to the RPC endpoint, the Ethereum RPC endpoint that we're actually pinging, and we've done the TLS handshake. Fantastic. Just packets coming in, packets coming in, packets coming out. And then all of this is actually, we're making a proper GET request to it over the Mixnet. So, okay, great, cool. So this is the content that we've got back. This is the page fingerprint. And let's actually check what it is. There you go, right? So for doing stuff that has the kind of, can take the additional latency where you want the privacy trade-off, considering I was talking when we were doing that, but we went through 3 stages there of actually doing TCP, TLS with an RPC endpoint and an IPFS node, actually like doing a bunch of calls, resolving a CID, and then pulling that down all over the Mixnet. So all without actually linking your IP address or fingerprint to either of those backends, right? Which are generally hosted by people like Cloudflare, whatever, right? Do I have time to look at the other one? Or yeah, sick. Okay, cool. So second one, which is very similar, but let's kind of kick it up a little bit. We want to interact with Railgun through the Mixnet. So we can do basically the same thing. We just write some shim code, okay? And what this basically, all this is doing is it's saying whenever for your RPC calls, so actually when you're constructing your JSON RPC provider, right? Usually it'll be like, well, what do you use as your HTTP client? In the browser, it's the normal browser's fetch. Here, I'll make sure to load up the browser console when I kick it off. But we'll basically see that our fetch request is just mixfetch. So again, let's grab the tunnel. And so this first bit takes a little bit of time, because as soon as I kick it off, then I've preloaded this web page with a Sepolia testnet wallet. And what's happening now is as I've kicked it off, we're doing we're having to fetch a bunch of stuff from the chain to actually re-resolve our Railgun address, because that is, we have to derive that basically every time that we load the page. And as we can see, all of our normal HTTP requests are coming through. One thing that I've tried to kind of focus on with building these is stuff like connecting pools and all of this. The way that you can think about it is your first connection out, or your first new connection, is going to take quite a lot of time because you're having to do stuff that presumes milliseconds at most with handshakes, and actually each of those has to go through the Mixnet, where you're adding maybe half a second to a second of latency. So like stuff like TLS, which is like with TCP 7 times back and forth, you're adding up a bit of a chunk there, but you can reuse that connection afterwards. Okay, cool. So in the time it took me to go over that, we've got our Railgun address. Fantastic. I've preloaded this in there. I've put a little note on here, but obviously it's not in the UI, but there is like a mnemonic on this page. It's just Sepolia testnet. No one be cheeky and pull it out because it's just to prove a point. But let's actually check our balance, right? So let's actually, what we're doing here, let me close this because it's a bit noisy. Okay, so we're actually building our JSON RPC provider, our normal Ether JSON RPC provider, which with the like 10 lines of shim code is then going to use mixfetch. We're calling get balance, and we've got our balance, right? So again, we from the browser have like made at this point a bunch of requests to Ethereum RPC providers without leaking our IP address or a bunch of other connection metadata about us, and also obfuscating the time. I'll go into the user header stuff in a little bit because that's like a bit, a bit more information there. It's a bit more nuanced. But then basically, okay, cool. Let's just shield some ETH. Let's do like the normal first half of what we would do with Railgun. As I'm talking, we can see that that has just gone through. So really, we're talking about a second. We've shielded some ETH, and that's it on Etherscan. So I don't have unshielding, and that's because I would have to have built a bunch of other stuff into this page to the extent that then I would have just like rebuilt the entire Railgun wallet into our documentation page. So I didn't bother, but I think you kind of get the point with both of those things, right? We're talking about ideally all of the stuff that you have to do in a browser that you don't want to do in a browser because you leak it to either to DNS resolvers, or you just kind of want to monkey patch your own HTTP and fetch stuff. Really, underneath this, it is actually like a browser UDP tunnel, which there's not a whole lot of use cases for immediately, but I'm sure someone could think of a cool one. And there is some interesting stuff that's come up with this, mostly to do with like all of the user agent stuff, because depending on who you're kind of trying to talk to through the Mixnet at the end, if it is someone like Cloudflare who have very, very good bot protection, you have to also think about that because your stuff starts to look slightly weird. The default user agent I've built into this, they ignore it the vast majority of the time, but there's some interesting stuff if you want to start using it. This was just our TypeScript SDKs. We also have Rust SDKs as well, but that's a bunch of command line stuff that was probably less interesting to watch. So thanks, and any questions would be, appreciated. Or no questions.
So you said that you're trying to create white noise in the Mixnet. If I was intelligence and could observe traffic, would I be able to differentiate white noise coming from the Mixnet versus non-Mixnet traffic?
Yeah, I mean, you watch the edges, right? But the idea behind with the idea with the cover traffic, and also basically the design of the Mixnet itself is based on this design called Loopix. So the idea is that whenever a client is connected to the Mixnet, you can see it sending traffic into it, but you can't tell like what that traffic is or when that traffic is actually being sent. Also, you can't tell whether, from just looking at the client itself, you can't tell because everything is being looped back around through it, you can't actually tell whether that's like a client sending in or a service that's actually getting some out itself, right? So you're kind of already, from that point, you're disintermediating, like, is this a sender or a receiver anyway, right? If you have that kind of God's eye view of a network, you will have additional stuff that will probably allow you to go, well, that's a residential address versus like that's in a data center, so we can infer different things about it. But as much as you possibly can, just off the basis of like how you move traffic around the network, we've tried to like break that apart. Yeah.
Latency per round trip, and did you have to tinker with the settings to get that for the demo?
Yeah, so tinkering with settings is a bit of a rabbit hole. It's a fun rabbit hole, though. So, like, I mean, if we go back to the playground, right, like, we can actually get that example for ourselves. Oh, wait, sorry. That's in our cache. So let me actually, let's resolve our own DNS, right? So, okay, cool. So that DNS resolution thing there, right? And remember, I'm actually pinging, let me check what I have in the settings. I'm either pinging Google or Cloudflare, just to basically prove that neither of those guys block you. Because if either of those guys block you, no one else is going to block you, right? So we actually we made a proper DNS resolution request, and it resolved in less than a second. That's a full round trip through the Mixnet. Yeah. So you're going Sphinx packets all the way through 5 hops to the thing at the edge, your exit gateway. That's pinging the DNS resolver, getting it back, turning it back into IP packets, tunneling it through the Mixnet back to us. And that's less than a second.
Settings, or were they chosen for the...
No, that's right. That's default. Like, the only thing that's not, like, default here is I run this exit because I'm doing a live demo, and I wanted to use a node that I know is really good because I run it. But, like, that's it, right? There is no other like config fiddling or whatever with this. You do start hitting stuff where you see like the round trip time assumptions of other crates start to affect you. So like this is a forked TCP/IP crate, which is compiled to WASM that underneath is running over the Mixnet. That's what is actually in this like WASM tunnel, right? That has certain assumptions about time and like round trip transmission that the Mixnet is too slow for, right? So there is like some configuration, but like very deep in the kind of like library, and that's all bundled in. You as a developer don't have to think about that necessarily. It gets more complicated if you're thinking about like peer-to-peer protocols, because they have like far stronger conceptions of time, timeouts, and all of this kind of stuff, mostly because they use that for essentially like building up like peer hierarchy maps. You know what I mean? Like libp2p, the basic thing you'll be doing as soon as you bootstrap into a peer-to-peer network, you'll mostly be pinging your peers to essentially get like a map of the ping time, which you will then probably use to weigh how you route traffic, right? So as soon as you're trying to run like a peer-to-peer network through it, it becomes a lot more complicated. But in this kind of situation, like where you're doing more like, let's say traditionally like client-server stuff, yeah, I've kind of tried to hide all of that away, but make it as like configurable as you want. I hope that answered your question. Cool.
All right, thanks a lot, Max.